Hello and welcome everyone to today's episode. Today we are going to be covering the following topics. All the timestamps are in the description below. And I hope you enjoy today's episode. So let's get started on these topics. Standard deviation is not part of LINQ feature within C#, so you have to work it out manually. So let's see if we can use a bit of LINQ and our custom method to work out standard deviation for the student marks. So here, as you can see, we have the following marks, and what we're doing is we are grouping by the class. So that's class history, maths, and science. So this will put them in groups and store the results here. Now that we have the groups, what we want to do is we want to loop through using for each, and we want to pick out each group. So what would each group contain? So all the students in math would be one group, all the students in science would be one group, and all the students in history would be in one group. So then you can use some built-in LINQ methods to do simple things like count. So you just basically have a group here, which is the class of the student. Then we simply use the count method on there, and this would give you count. Average, of course, for average, it needs to know which column to do the average on. So we want to do it on the marks column. So you use the lambda operator here, pass in the student, and just basically select the marks column for each student. So again, this is a built-in function within LINQ, but for calculating standard deviation, there is nothing built in. So we have to write our own custom function to do that. But we pass that custom function to the group because we are looping through the group of students. So all the maths student, all the science and history, they would be passed through to the standard deviation function. And then we simply have a write line to output the variables we have here, which is the count, the average, and the standard deviation. So let's have a look at the standard deviation function. So this gets called as we're looping through this, and you can see what we are taking in is I enumerable students. So we could have used the list here, but you have to use I enumerable student because of the delayed execution. So essentially it doesn't need to create or allocate memory for the students immediately. It can just do it one by one. So here you can see that. So what we're doing is we are selecting students coming in here, and we are using the select method of LINQ. We're using the marks column. So we're passing each student here and selecting the marks column and converting it to a list. Then we are basically checking how many marks there are. So we're just simply doing a count of the list method. So this is now a list date type over here because we converted it to a list. So we can use the count here, and this is a count property, so we can just use that. And then we're checking if the count is less than 1, then basically early return to 0. We don't need to do rest of this. So otherwise we take the average. So again, we are just using the marks variable here. So the marks variable here is being used here to get the average, and then we're using sum of squares. So again, we're using marks, and what we're doing is for each mark within the list, again, we are using the LINQ here, using this formula over here. And then what we are doing is we are just going to divide the sum of squares variable by count minus 1, and this will give us our standard deviation, which we pass back over here. So this is an example where there is nothing built into the LINQ feature of C#, and instead you have to write your own standard deviation function and then use LINQ features here to use the select method to convert your marks to a list, and then use them over here. And then you can use lambda as well to write your formulas to make things easier. So whereas previously it was simple, you could just use the built-in like average function, but now this is something that's not provided by LINQ, so you have to write it yourself. So let's try and understand the GroupBy a bit more detail and see what if we manually wanted to replicate some of the GroupBy features. How would we do this? So if we didn't have LINQ feature in C#, how would we do this? Where we have a bunch of students, and what we want to do is we want to group them by their class, such as math, science, history, and then maybe get a count and the key value. So what are they being grouped by? So here I've tried to replicate the GroupBy. So you can see you've got your students here and the subjects that they are in. And what we want to do is we just want to put them in their class group over here. So they're separated by the subject they are doing. So what you do is you could create a dictionary, and this dictionary has a key, which is in string, and then values are list of students. And we'll call this variable groups. So we'll create a new instance of this. And then what we're going to do is we are going through and loop through our students. So that's the students we created here. So that's the students variable there. And when we are looping through them, what we'll do is we'll store this current students class as the key in this variable. So the variable is called key. And then what we're going to check is if the groups, so the groups here is the dictionary variable we created, and we're going to check if it contains the key. So the key is the class of the current student. So for example, Ali is the first student, and we are going to check if the class is math. If it already exists, then that's fine. We won't do anything. But if it doesn't, then what we'll do is we'll create that key and initiate a new list there. So this here is just the if condition within these two brackets. And then we are going to add add the student based on the key. So the key again is the class here of the student. So this would be, for example, history. And then we are going to add student to the values. So the values are actually just a list of students. And remember, we created the new list here if a key was not found. So within these brackets, that's what it's going to do. So by the time we come to this slide, we already have a list of students, and we can just simply use the add method. And then we can loop through that variable, which is the dictionary variable we created. So each key value pair, so KVP, we will get the key from that dictionary, and its values are of course just a list of students. So its value is going to be that, and that these would be our group members, so which students belong in each class. And here what we're going to do is we're just going to print the class name because that's the key, and we're just going to count to the count property of the list to print out how many students in each group. So if I run this code here, so as you can see here, we've got the math class, we have 2 students in there, Ali and John, and then we have the science class, Sarah and Zara, and we have found here of 1 for Tom because he's the only student in history. So this is a potential way of replicating what we saw with the GroupBy and how it's working. This is not the exact way it's working because it's a bit more complex than that, but just to give you a brief idea on how the GroupBy could be implemented. But of course, because of the deferred execution, it will not be exactly like this. This is just to get this concept clear in how you could replicate this. Let's try and understand dictionary data structure in C#. This is very useful data structure. It allows you to store key and value pairs. So here what we're doing is we're creating a dictionary that holds the key, which is in string data type format, and the value is also string. And our variable is called countries. So what we're going to do is we're going to add countries. So here we are adding using the variable name. We're using the add method here. So the add method here will add US, for example, here as the key, and the value would be United States, and UK as the key, and United Kingdom as the value, and FR as key for France. Now, in order to access an item with a dictionary, you use the variable name and the key, and that will give you the output of that value. And then if I run this code here, so here you can see we provided a key and we got the following output, which is United Kingdom. And then we are checking if a key exists. So FR does exist, and we get the output FR is in the dictionary over here. And then what you can do is you can loop through the dictionaries using for each. So these are key value pairs. So we're just naming this temporary variable here. So it's going to go through each dictionary item. So our variable that holds the dictionary is called countries. And what we're going to do is we'll loop through that. So each country, of course, has a key and a value. So that would be, for example, FR for France. FR would be the key, and France would be the value. So then you can do it. You can also remove an item from your dictionary by using its key. So we again call our variable here countries, and we're calling the remove method and providing it with a key of FR. So this will remove France, and then we can see a count of items within our dictionary variable by using the count property. So if I show you that down here, so you can see France was removed. So we were only left with 2 because originally we added 1, 2, 3 countries. But once we came here, we removed France. The property reflects this as 2 countries left in our dictionary. Within the dictionary data structure in C#, you cannot have duplicates. So here what we're doing is we've got a variable called student courses, and the dictionary itself will take the key as string and the value as string as well. And what we're doing is we are adding a few students. So here Alice is the key, and this Matt is the subject, and that's the value. And then Bob here is added on, and he does history, and James is added on, and he does art. But what if Alice wanted to do another subject other than math? So she currently only does math, but what if she also wanted to do science? Is that possible? That's not possible without first removing the previous entry, which is math. So you can use the remove method here to remove the previous item in the dictionary and then add in the new one over here. But that is not what we want. So if I run this program, you can see that my code does work and there are no issues, but you cannot do this. So if I comment this line out and enable this line over here, you can see now we are going to add in, without removing anything, we are going to add in science and math at the same time. And what will happen is we'll get an error after the code tries to run. So here, this is a runtime exception. And what you're getting the error for is that the key Alice has already been added. So it has already been added, so you cannot do this. So how would you get around this problem? So instead of declaring 2 strings like this, that's the key and that's the value, what we can do is the value actually actually can be a list. So here you can see I've left the key to be string, but the values of the courses that the student does is actually a list. So here what we're going to do is, you can see we're creating Alice, and notice that we are able to pass in math and science. And then later on, when Alice also wants to do history, we can add that over here. So notice that the difference between add here, the add is related to this particular key, whereas previously we have used student course here and the add is here. Notice that there's no key specified, but the difference here is we are using the add method of the list, because this is a list type and we're using the add method there rather than the add method here. The add method for the actual dictionary is directly after the variable name is mentioned. So that's an important difference to be aware of. So then you can again add Bob as well, and he can do English. And then when you want to loop through the items and work out which courses each student is doing, notice that we're using the variable here, student courses, which is also over here, and we're getting key value pairs. We're getting the key, which would be the student name, and then using the string join method, we are passing it our list here, and what this will do, doing that together. So if I run this code over here, so you can see Alice is doing math, science, history, and Bob is doing English. So you are able to have multiple items in a dictionary, but you just need to use the list date type, which can hold strings, and then use the add method here to the actual key, because that is the add method for the list. There is another very useful method in LINQ called OrderBy. What it allows you to do is, let's say you have a list here. This is your variable, and you're going to add the following people into your list. And what you want to do is you want to sort that using LINQ. So here you're going to declare a variable called sorted by age. Notice its type has to be var, because this will return I enumerable. So it's easier to use the var keyword. And then you can pass it your people object. So here the P is referring to the people variable that you have here. So this is where you declared it, and you're using the lambda operator here, and then sort selecting the field age, and this will sort the items by that. Now, if you want to sort by multiple fields, so let's say you want to sort by age first and then by surname, then you can use the then by method here. Now, none of this code will get executed at this point. So when you declare these here, these will not get executed until you loop through them. So the query, if you have, let's say 10,000 items in your list, those 10,000 items in your list will not processed until you reach the for each loop, where it will have to go through and sort them and load them into memory. So here, when we do the first one, which is sorted by age, if we execute this method here in the for each, then the second sorted variable will not be loaded and sorted. It will be only loaded and sorted once it hits the lines here. So that's why LINQ is known as lazy evaluation and deferred execution. So it doesn't execute until needed. And then of course you've got another method here, which is you just have a list of strings, and what you want to do is you just want to just sort them by a variable called name, which you are defining here and using the lambda operator passing it there. And then you've got the sorted names, and that's a temp variable, and you're just printing out the output. So if I run this code over here, you can see the names are in this example sorted in this order: Ali, James, John, and Sam. But if I run this example here, which is sorted by age and then sorted by age and name, so if I run this here, we will get two printouts. So you can see the first one is just sorted by age, so Ali is the youngest, then James, then Sam, and then John. But then we have the next list, which is sorted by age and then by name. So you can see here John and Sam have swapped position, although both of them are 35, because John comes first in alphabet and Sam is afterwards. So by using then by, you can double sort your list first by another variable and then by another variable. Let's learn about the first LINQ method here, and also FirstOrDefault, and understand the difference, and also understand why should we use them instead of something else. So here I have a people variable that will hold list of person, and list of person is basically just a class with name and age. And the difference between FirstOrDefault is the first one will throw an exception if the criteria that you specify here does not match. So here what we're doing is we are looking for the name field here, and we are checking if Bob could exist. Now we know Bob exists, but Bob with number 2 at the end does not exist. So what it will do is throw an error to say invalid standard operation. So you need to encode that within try catch, otherwise you will get an error. So the alternative is using FirstOrDefault. So what this will do is if it cannot find this person, David, for example, who is not in our list over here, what it will do is return a null. So then we can use an if condition to check if person 2 is null. So rather than throwing an error or an exception, it will return a null. Now you can change what it returns. Although null is the only default value returns, you can then use the null coalescing operator here. So what this will do is if this expression here, so all this, if it returns null, then you will get the default person. And what is that default person? We've defined it here. So this will just have name of default, age of 0. So if I run this code here, so you can see the outputs that we get over here is person not found using first. So this is the error code here that got triggered because it could not find Bob. And the second one using FirstOrDefault, that's basically being used by our null check here. And we've got the else here, and it says person not found by FirstOrDefault. And of course, the third option we have is where we are returning the default type using the null coalescing operator here. Basically, this side returns null because that's what FirstOrDefault returns. It returns null if David is not found. Then it will basically use the default person, which we have defined here, and that's the variable name. So why would you use FirstOrDefault? What if you wanted more items returned? So if you had multiple people called David or multiple people called Alice, Bob in your list, then you would not use the FirstOrDefault because this will only return the first value that's in your list without returning all of them. But if you want to return all of them, then you should use the where method. But notice that the where method returns a collection, enumerable, while the type return is a single item or null for FirstOrDefault. So here you are safe to use, for example, when you use FirstOrDefault, normally you can use the var keyword. In this instance, if you wanted, you can actually use the person class itself because it's only returning a single item, unlike where, which actually returns a collection of enumerable, but you can find out more about in my other explanations. So that's why when you do get type on the person variable here, you get person slash as the output because that's what it's based off. Even if you were to use the var keyword here, it would still return the person class because the compiler will figure this out that you're using first method here or FirstOrDefault method here. Let's now try and understand SingleOrDefault methods in LINQ to see what the difference is. So let's have a look at this example. We have a list of people within here based on the person class. So you can see the person class just has an ID and a name. So here we are adding in a person with ID 1, James, and a person with ID 2, Stephen, and a person with ID 3, which is James again. The reason for duplicates here for James is very important to understand the difference between single LINQ method and SingleOrDefault. Now you may have come across in my previous explanations FirstOrDefault. So here FirstOrDefault. So as you can see here, first and FirstOrDefault are used to check the first match in the list. Default, of course, is to deal with nulls if you do not find a match. But the difference between single and the first method is single will return the only match. So it must be exactly one, the only match. That's what we are looking for, or null if none is found. So if you get multiple matches using the single or SingleOrDefault, then we want the code to error and we want to know there's something wrong. For example, a person with the same ID shouldn't exist, so that's an error. While with the FirstOrDefault, this is allowed. We don't care about duplicates as long as one is returned. So if we have a look at the code here, so you can see James exists twice in here. Now, if we get exactly one match, which is based on the ID number here, ID number 2, then we are fine. There's no issue with that. But if we get multiple matches here for James, because he appears twice here, one with the ID 1 and the other with ID 3, then we have a problem. So it matches ID 1 and 3. So we want this code to error and it will be caught by this exception because the single method's purpose is to only return one record. If multiple records are found, then we want it to error. And the default, of course, is if no returns match, so 99 ID doesn't exist, and we just want it to return null, and that's not an error. While with the single method, if a no match is found, for example, here, if we had 99 here, then we want it to trigger the catch close. While with the default method, what it will do is it will actually execute this line and it won't go into the error state. So that's the difference between SingleOrDefault versus single. But remember, it must match exactly one. Otherwise, in both instances, whether single or SingleOrDefault, the error catch would be triggered here. If you do have multiple matches in your data and you don't care about duplicates, then you should use FirstOrDefault. So let's run this code. So as you can see here, Stephen is returned because he's the only one. But when we get two Jameses here, then we get an error. So this is an exception as co-host. But if it is null, notice notice it's not an error because we are using SingleOrDefault here. So just remember, if you have duplicates in your data, then use FirstOrDefault. It will just return first record. And if you have duplicates and you want to make sure those duplicates cause errors, then use this SingleOrDefault. Let's take a look at these two important LINQ methods, take and skip, because they allow you to build some very useful logic in your code. So here we have a list of people, as you can see. They are based off a person class. So here, as the person class, just have ID and name. What the take method does is it takes the first three people, and it will only take those first three people and write their name. So the first three elements. So this would be Tom, Ali, and John. Now, if you skip the first two, for example, skip Tom and Ali, and John will be printed, and James and Zara. Now, an interesting thing you can do is with pagination. So with pagination, you can actually print records that only appear on a certain page. For example, if you have page sizes of 2 and you are on page number 3, then if you were to split your records up, so the 1 and 2, so that's the first page, and you have 3 and 4, those would be on the next page, and finally the last one would be on page 3, because each page can only have 2 as you specified in the code here. So here page size is 2 and we want to do the third page. So here you can see what you do is skip the relevant number of records depending on the page number you are in, -1 of it. This is just a standard to refer back to the previous element, and then multiply that by the page size. So page size is here and you just multiply that. So in this instance, if you've got 3 here, 3 minus 1, that would take you to 2, and 2 multiplied by page size of 2, that'll give you 4. So what it will do is skip the first 4 elements as a result of this and give you then, using the take method, you would take the relevant number of elements, so which is 2. So in this instance, if we've got 4, so 1, 2, 3, 4 being skipped, because of the skip method here, those would be skipped, and then finally you just use the take method. So we will skip 1, 2, 3, 4 and just basically show this one over here, which is only 1 element, but if there were more, then of course it would do 2 elements there. So if I run this code over here, so you can see here when we use the take 3 method, it will take the first 3 records. So you can see Tom, Ali, and John being selected. So you can see Tom, Ali, and John being selected because they're the first 3. And after skipping 2 elements, so if we have a look at our code here, this is to skip 2 elements. Those 2 skipped elements would be these 2. So these 2 would be skipped, and then you just basically get a printout of John, James, and Zara, which is what we get here. And then you can see finally in terms of paging, you can see Zara is printed, but let's say we were on page number 2, then we should get on page number 2 the elements John and James. So if I just change that to page 2, page size remain the same. So if I run this over here, you can see it will get John and James because they are supposed to appear on page 2. So this lets you build pagination using 2 simple LINQ methods, skip and take. Very useful to know and understand what they do. How would you do pagination using LINQ in C#? So let's have a look at this interesting example. So we have a list of people here. So we have the following list of people, and this is based off a class that just has ID and name, but it can be anything that you want. So here, what we want to do is we want to have a page size of 2. So just imagine we only want 2 elements to appear at any given time, depending on the page that the user is on. So what we'll do is I'll just run this code to see the output that we get, so you can understand what is going on, and I'll explain the code. So here you've got page 1, and it's got Ali and Sarah, and then you've got page 2, which has got John and Tom. You've got page 3, which has got Zara and James. So here you can see how the pages are working: page 1, page 2, page 3. So what we're doing is we just want to loop through the pages. So we want to have maximum of 3 pages, and we want the page size to be 2. Initial page number, of course, is 1, and then each time we loop through, we just want to increase the page number by 1. So when we are on page 1, we just want to print the page number. So in the output that you saw, so you can see here that we print page 1, and then afterward we print who's in that page. So if we have a look, then what we do is using the skip method and the take method, which I have explained before in my other explanations. So what we're doing here is we're just getting the page number variable, which will be 1 for the first page, and then we just -1 of it and then multiply it by the page size. So for the very first page, it'll be page 1, 1 minus 1 equals 0, 0 multiplied by page size of 2, it's 0. So it will skip 0 records the very first time it runs. Then it will take the page size, which is 2 elements. So you saw here page size is 2. So it will take take the first two records and print them out. And that's what happens. Ali and Sarah are printed. Then when we get to page 2, what it will do is this, of course, page number there will be 2. So 2 minus 1. So this would give you 1, and then multiply by the page size, which is 2, because again, page size is 2 there. And 2 multiplied by 1 is going to be 2, and it's going to skip the first two records. So we'll skip Ali and Sarah, and then using take method here, which is page size of 2. So we only want 2 elements per page. So here you can see John and Tom are printed. And finally, when we get to page 3, we get Zara and James. This again is going through the same logic. 3 minus 1 equals 2. 2 times 2, which is the page size again, which will be 4. So it's going to skip the first 4 elements, 1, 2, 3, 4. And then it's going to take the page size again, which is 2 elements at a time. So it's going to print Zara and James. And what we do here is we just loop through and print the ID and the name from the P variable here, which is a temporary variable that actually then is the page data. So remember, the pagination is very good in LINQ because your actual code to pull this out won't run until the for each loop is run. So all these methods skip and take won't actually physically run until you actually execute the for each loop. And that's doing it 2 elements at a time for us and going through this loop. Check out my other explanation where I can show you how you can jump between different pages. So pagination is very easy to do using just 2 simple methods, skip and take, using the LINQ query language in C#.